Alright, let's look over what we know about functions. A function is a relation where every input has one output. Functions can be represented with graphs, tables, mapping diagrams, and coordinates. Some examples of functions in real life are using the codes on the vending machine, an elevator, or getting seats to a concert. So methods to test if something is a function. There are quick ways to determine if a relation is a function. If you're given coordinates, you could list the coordinates in a mapping diagram and see if there are two arrows coming from one of the inputs. If you graph them, you could graph the coordinates and see if any of the points are stacked where they're lined up on top of each other. And then the third method is to use a table and see if any x values are duplicated and that give you different y values. So let's review what we learned on Friday really quickly. We practiced doing the vertical line test. So one method to testing if something is a function is called the vertical line test. If you draw a vertical line anywhere through a function, so vertical line is up and down, and sometimes you can just use a ruler to go straight across. So let me grab a ruler. If I take my ruler and I draw a line at any point going through the function, so I can draw a line there, there, there. So taking a look at each of these lines, they only hit the graph once. So because they're intersecting the graph only one time, this is considered to be a function. It's not a function when you draw a line and it goes through the graph more than once. So again, if you use your ruler, you can physically draw lines and see, does it cross the line more than once at any point? And here it's crossing twice, twice, twice. You can use your ruler and kind of slide it, and you can also just slide to see, and you can see that it's hitting it at 2 points no matter where you're sliding. And here it only hits it at the 1 point. So that's just a quick review of the vertical line test. So a relation is a function if and only if no vertical line intersects the graph of the relation at more than 1 point. So the vertical lines are just hitting it at 1 point. So use the vertical line test to determine whether if each graph is a function. So if I slide my ruler, I'm only hitting 1 point there. 1 point, 1, 1, 1, and 1. So this one is a function. Let me redo that. Only hitting 1 point, 1 there, 1. So you can see it never hits more than 1 point with my ruler when I'm sliding it through. So this makes this a function. Versus the other graph, it starts off okay, but then look what happens as you slide down. Looks like right there, there's 2 points that are lined up, kind of stacked on top of each other. And if I draw a line, you can see it goes through both of them. And then it happens again here as well. So you could be able to tell me that this is not a function because there are inputs that give you 2 outputs. So having this understanding of functions allows us to explore some other aspects of functions. So one topic we're going to be working on is determining the domain and range of a function. Domain is a word that means all of the inputs of a function, so all of your x values. The range is all of your outputs, so that's your y values. So for example, let's say you have a vending machine where inserting 25 cents dispenses 1 pencil. Inserting 50 cents dispenses 2 pencils, and so forth, up to and including 10 pencils. So let's complete the table for the situation. 25 cents is 1 pencil, 50 cents is 2 pencils, 75 cents is 3 pencils, $1 is 4 pencils, $1.25 is 5 pencils, $1.50 is 6 pencils, $1.75 is 7 pencils, $2 is 8 pencils, and $2.25 or 9 pencils. And finally, the most you can do is 250 to get you 10 pencils. So if I ask you what is the domain of this situation, the domain is all of your inputs. So all of our inputs are in increments of 25 cents. So I could list my domain 25 cents, 50 cents, 75 cents, $1, $1.25, $1.50, $1.75, $2, $2.25, and $2.50. Just based on the table, this is the domain of the information that I have listed in my table. The range is the outputs, so I can get 1 pencil, 2, 3, 4, 5, 6, 7, 8, 9, 10. Writing the domain and the range, you write them in order from smallest to greatest, and then you just list the values that are within each of them. So my domain is all of my x or input values, and my range is all of my output or y values. So let's take a look at some of the problems we've seen and see if we can identify the domain and the range. So given this table, identify the domain and the range. Remember, the domain is your x values, and the range is your y values. So for my inputs are always your x's, and outputs are always your y's. So to my domain, I'm going to list it in order. It goes from 3, 5, and 7. And I put these little curly brackets because this means it's a set. So this is the set of my numbers that are in my domain. My range is my outputs in order from least to greatest. Doing it again on my mapping diagram, domain is my input, so it's my first oval, so it's 2, 6, and 8. My range is my y values, -3 and 4. On a graph, you look at your x values, and then you compare them to your y values. So my domain, where there are dots, I have a dot at 2, 3, and 5. So it's 2, 3, and 5. For my range, my lowest y value is 1, then 3, and then 4. So these are the possible values in my domain and in my range. Again, the y values are your range. So this is 1, 3, and 4. From coordinates, you can also figure out the domain and the range. So listing my coordinates, I've got -7, -6, and 9, because these are all my x values. My range is my y values. So that's -3, 0, and 2.5. Again, make sure we put those numbers in order from smallest to greatest. One last practice. Sometimes you'll see a graph and it'll ask you to describe the range and the domain for the function listed. When it's listed as a graph, you have to list all the possible answers that could possibly fit into the domain. So we use inequality symbols to do this one. So if you take a look, for this graph, the furthest to the left I can go on this graph is -1, because that's where this endpoint is located. And the furthest to the right I can go is positive 1, 2, 3, 4, 5. So in my domain, I would list it as -1, less than or equal to x, less than or equal to 5. They have solid dots, so they're less than or equal to, and now this range covers all the possible numbers between -1 and 5. For the range, I have to go as low as I can, which is -1, to as high as I can. 1, 2, looks like it only goes up to 2. So I'm going down to -1. This time I use my y values up to 2. because my range is all my possible values on the y-axis, and my domain is all my possible values on the x-axis. So that covers all the possible numbers you'll see. Try the practice problems. Remember, domain is all of your x values and range is all of your y values.